All right, we are going to get started with our lesson on vectors. So our first objective today is to actually learn what a vector is and describe a vector. A vector is any quantity that has a magnitude and a direction. Okay, so magnitude is size. So a vector is a quantity that has a size and direction. The magnitude of the vector corresponds to the distance from the initial point to the terminal point, okay? So vectors kind of look like, it's not a line, it's a direction. It's a size and a direction. So here it's the velocity at which this whale is jumping out, which includes its size and then the direction in which it's jumping out. So magnitude corresponds to the distance between the initial point and the terminal point, and the direction corresponds to the direction in which the arrow points. Okay, this whale is jumping. Oh, I would assume this is north because I don't know the story here, with a magnitude or a size of 25 miles per hour. Okay. All right, so we're going to go ahead and describe this vector in what's called component form. And take a look here at what component form means, okay? So in component form, before we actually do this problem, component form is used to represent a vector, and you use this notation x comma y, okay? And notice how it's these notations and not parentheses, okay? So if it was parentheses, it would be a point on the coordinate grid. Because it is these little, I don't know what you call them, like little arrow type things. Because it's these little arrow type things, that is a vector notation, also representing that arrow of the vector. So this is vector notation or component form, not to be confused with an ordered pair, which is a coordinate grid on the coordinate plane. Remember that the magnitude and the direction of the vector correspond to the distance and direction of xy. Okay, the magnitude and direction of the vector correspond to the distance and direction of xy. So let's take a look at what that means. All right, we have here a coordinate grid. We have here a vector. This is the vector right here. And our job is to describe the vector in component form, then round our coordinates to the nearest tenth. This 51 represents the magnitude of the vector. All right, and we're going to go ahead and form a right triangle here. Okay, and we have this is 55 degrees. We have that's 90. This is our x, and this is our y. All right, so obviously we can use the little right triangle trig here to find the component form, to find the direction of x and y of this magnitude. So we go ahead and do a little sine and cosine ratios to find x and y. So we can say that cosine of 55 is equal to, that's adjacent over hypotenuse, so x over 51. And we can say that sine of 55, which is opposite over hypotenuse, is y over 51. So we do a little calculator work in algebra here. Okay, and just grabbed my calculator there. So x is equal to 51 times cosine of 55. And y is equal to 51 times sine of 55. And pulling out my calculator, and we're rounding to the nearest tenths. So x is 29.3. And y is approximately 41.8. All right, but now you have to take a look and see that x is in the, or this vector, sorry, is in the second quadrant. So x is negative and y is positive. So in component form, that is a negative 29.3, and y, which is positive 41.8. So to recap here, we were given the magnitude of the vector, once, and the direction, and once you know that and a degree here, the degree and the direction, we were able to drop a line and make a right triangle, and we used cosine and sine to find the x and y components of the vector, rounded to the nearest tenth, and kept in mind that we did have to look back since since this vector is in the second quadrant, x is negative and y is positive. All right, so moving on to describing a vector's direction. So in many applications of vectors, now this is in your book, not in your notes, but I went ahead and made a copy of it here for you so you can take some notes. In many applications of vectors, we use compass directions, north, south, east, west. So hopefully you know your compass, north, south, west, east, east, west. We is how I remember it. And we are then being asked, what is the direction of each vector using compass directions? Okay, so take a look at A. The angle below is 25 degrees, is south, the west-east line on the east side, okay? So this vector is 25 degrees south of east. South of east. So 25 degrees south of east. Right here, this vector is to the right, okay, to the right of the north-south line, on the north line. So this vector is east of north, 35 degrees, sorry. East of north, 35 degrees east of north. So this one would be 18 degrees east of north, 18 degrees east of north. If you're over here, it would be south of west, south of west, okay? So hopefully that gave you enough directions to then sketch a vector that has the given direction. So let's say we want to sketch a 50-degree vector, 50 degrees south of east vector. So we'd be looking at east, and we're going south of east, which is right here. And that would be, make a little arrow to show it's going this way. Do that in blue. That's 50 degrees south of east. So that kind of caps off for you describing a vector direction using compass directions. All right, so here we are going to go ahead and look at number 5. We're going to use that vector A has components 6, 1, or is equal to component 6, 1. And we're going to find the magnitude of A. Keep in mind that the magnitude of a vector is the distance from the initial point to the terminal point. So if we were to draw a triangle here, the magnitude of the vector is the length of the hypotenuse. The magnitude of the vector is the distance from the initial point, 0, 0, and the terminal point, which in this case is vector component 6, 1. So it's the hypotenuse of this triangle, all right? The x-axis, or the bottom leg of this triangle, 6, because that's the x component, and the y is 1. We don't know this angle. Okay, let's call that x degrees. So we can easily find the magnitude by using the distance formula or the Pythagorean theorem, because, hey guys, the Pythagorean theorem is the distance formula if you take the square root on both sides. Okay, now the reason why we're going to use a distance formula, though, is because this vector is starting at 0. I mean, you could use the Pythagorean theorem, sorry, because this vector is starting at the origin, 0, 0. So if you use the distance formula, you're going to do 6 minus 0 squared and 1 minus 0 squared. So we can just do the Pythagorean theorem, but either way, let's go ahead and just do distance formula. Again, is the Pythagorean theorem. So x minus x squared, so terminal minus initial squared, plus y minus y squared. We're looking for the distance of that line right there, also known as, that is the magnitude of the vector. That is the distance from the initial point to the terminal point, the length of the arrow. So we can write this as 36 plus 1, the square root of 37. So your distance is equal to the square root of 37, which, let me grab my calculator, is, hold please, 6.08. What are we being asked? It didn't specify, so 6.08. Let me make sure I rounded that correctly. Yeah. All right. That is the magnitude, or the distance, between the initial point and the terminal point. Now we need the direction, okay? The magnitude of a vector is the distance from the initial point to the terminal point, and the direction corresponds to the direction of the vector points. So this is 6.08. All right, and we're going to find the vector's direction. So to do so, first find the x degrees formed by the right triangle, right there. And let's go ahead and find that angle, and let's use what we were given. We were given 6,1, just in case we got this wrong. I'm going to do tangent of x is equal to opposite over adjacent. Okay, and we're going to tan inverse on both sides, so we get that x is equal to tan inverse of 1 over 6. That's going to give us that x degree. I'm going to pull out my calculator. Tan inverse of 1 over 6. Oh, but it's multiplying the square root of 7. Let me erase that. That's 9.5. So I get that x is equal to 9.5 degrees. All right. So this, let's call this, I don't know, let's pretend this is an airplane or who knows. Anyway, the magnitude is 6.08 with a direction of 9.5 degrees north of east. 9.5 degrees north of east. 6.08 is the magnitude. I don't have any units for this. It's not a story problem. 6.08 with a direction of 9.5 degrees north of east. All right, the last thing we're going to cover is solving problems involving vector addition. Okay, when you add two vectors, the answer is another vector. Okay, so when you add two vectors, you're adding two magnitudes and directions, and then you're going to get another vector. So the resultant of the other two vectors, or the answer to the sum of two vectors is the resultant. It's the resultant vector. It's another vector. And this is actually really easy computation-wise. It's just talking about exactly what's happening. So it's computation-wise, it's really easy. You say you have vector A at x1, y1, and vector C at x2, y2. The sum of them is really just adding the coordinates. So you're adding the x's and the y's. That's vectors A plus C. And when you do that, you're going to get another vector because you're going to get new components. So the sum of two vectors is a resultant vector. So obviously the sum of these two vectors, the resultant vector, would be still -5, -7, because you're adding -5 with 0 and -7 with 0. That one's kind of silly. All right, so let's say you had to add vectors -4. Let's call this one vector A. Oh, and that's your notation for vectors, kind of like a little arrow-looking thing. Let me make it nice. There we go. Let's say vector A has components -4, -3, and vector C has components 1, -2, okay? And you were asked to find the resultant. Let's call the resultant E. Find the resultant of the two vectors as an ordered pair. Remember, the resultant is the sum of the two vectors, which is also a vector in and of itself. So E is going to be -4 plus 1 and -3 plus -2. Okay, so vector E has these components. So I want to show you, we know how to draw vector E if we started at the initial point of 0, 0, and then ended at the terminal point of -3, -5, and then drew a line. Okay, but I want to show you something. So let's draw first vector A. So vector A is -4, components -4, -3. Okay, so vector A looks like that. And vector C is at 1, -2, but we're adding A and C. So vector A happens first, and then vector C happens next. So this is now the initial point of vector C because we're adding this movement with that movement. So let's go right 1 and and down 2. So there's vector C's terminal point, more or less. As I went 1, 1, negative 2 from this initial point. So vector E is the result of the sum of A and C. I know I'm not on a nice grid, so more or less, I know I'm completely off here, so let's call that negative 3, negative 5. 1, 2, 3, 4, 5, yeah. All right, if this was correct, and you can see this one in your book nicely, if this was correctly spaced out, that would be about negative 3, negative 5. There's your vector E. So you can visually see how vector A plus vector C results in vector E, with initial point here, terminal point at the conclusion of A and C being added together. All right, last example. So let's say you've got vector A here at negative 4, 4. And you did have to find those yourself. And let's call vector B here at negative 4, 2. And the question is, write the resultant of the two vectors as an ordered pair. So let's call the resultant C, vector C, and that is going to be 0. Negative 4 plus negative 4, which is not 0. Hello. Negative 8. And 6. Okay. So vector C should be negative 8 and 6, and it's the resulting of the sum of those two vectors. So negative 8 and 6, which is vector C. Now, one thing I want you to notice, let's draw a nice line. There we go. Okay, ignore that first yellow line. That was not a nice line. Okay, there is vector C at negative 8, 6. Now, this wasn't the bounce one like we did over here because vector A and vector B were both having the same initial point of 0, 0. If we wanted to see this result, we'd be putting vector A, and then we'd be going left 4 and down 2 from vector A to then draw vector left 4, down 2, to then draw vector B, which would then result in vector C. Left 4 and up 2. Left 4, up 2. There we go. That makes sense. Okay, that would be vector B. And then to make the triangle, you would connect it with vector C. So try it. If you want to try that, you'd go, this would be the initial point of vector B. And you go left 4, up 2, and you connect that line. And then you close it off with a triangle. Close it off to make a triangle, and that should get you to negative 8, 6. All right, kids, listen. Here's what I need you to do. At this point, you're going to move on to the second part, which is going to have you reading in your textbook. Check Canvas for those pages. Once you finish reading that textbook, submit the notes, and then work on the next task. Thanks for watching.